load-in and hold-in one. And we have 3 learning objectives. The first one, we want to explain the cycle time, fixed time, and variable time. Then we calculate the rolling resistance, grade resistance, total resistance, and effective grade. The third objective we want to achieve is to determine the attainable rim pull, maximum speed, travel time by using performance and retarder curve. And finally, we want to estimate productions of tractors and dozers. So let's start with the first objective is the cycle time, fixed time, and variable time. Variable time. Basically, the general equation for relationship between these 3 times, we can say cycle time, it should be equal to fixed time plus variable time. So that applies to any equipment operation. And the question comes is, what is variable time? So variable time, it basically change of travel time, and that contributes significantly to the efficiencies of the operation of the equipment. And of course, will depends on the 2 factors. The first one is vehicle resistance to movement. Resistance to, and that basically the friction, etc., that make the resistance. And then what is the maximum speed of the vehicle? So you cannot exceed the maximum speed dictated by the manufacturer. Maximum, just like our car, maximum speed. So those 2 will determine the travel time or the variable time. Fixed time, basically the turning, etc., when the equipment in the sport. From that, what is the resistance we are talking in here? And that the next topic we want to investigate, which is the resistance and rolling resistance. And rolling resistance. For example, in the dozer that you see in here, there are 2 types of the resistance that you can see to move this vehicle. The first one, you can see that is the grade, because for example, in this case, the dozer go uphill, then they have a rolling resistance. If you go downhill, it's much easier than go uphill. That is one resistance. The second type of resistance, we call that a rolling resistance. It depends on the material. If here on the dirt, it's difficult to move. You drive your car on the dirt, it's difficult. Have more resistance than drive on the asphalt or concrete. So those are the 2 resistance and that we are going to talking about. So basically, the total resistance, it will be a grade resistance. How slope will detect that one resistance. If we go uphill, it's more difficult. It means that more resistant than going downhill. The first one. And then the second resistance that contribute to total resistance of the equipment that detect the travel time, it will be the rolling resistance. It depends on the material that the equipment moving on. Rolling resistance. So let we investigate for each of these resistance here. The first one we talking about the rolling resistance and how it measure. So the first, in some of the resistance, it will be measured with the resistance factor. And what should be the unit? Of course, they have a SI unit and foot pound system, and that have in the book. I just use one in here for domestic here with foot pound system. It measured by pound per ton of vehicle weight. Ton of weight. So that's the resistance factor. And for the rolling resistance factor, the first resistance we want to talking about. So the rolling resistance factor. The equation is, and it again measure pound per ton of vehicle weight. And for foot pound system, it will be equal to 40 plus 30 times inches penetration. So basically, to determine the rolling resistance factor, we can measure how many inches the wheel penetrate to the material, to the grade, and that will apply in this equation 40 plus 30, and the inches of the penetration in measure in inches, you will get that pound per ton. And to make it easy, if they don't give it, we can use the table, and I write down here. We can see table 4.1, and that also slide number 2, we can have that. And I'm going to show now with that table. So this is the typical value for the rolling resistance factor, and it depends on the material that the equipment rolling on, as you can see. So if concrete and asphalt, the rolling resistance is smaller, 40 pound per ton. If it kilogram per ton in SI unit, 20. If firm, smooth, flexing, slightly under load, so 64. But if you go to the soft, muddy, deep rutted, it go up to 340. So that, as you can see, vary a lot. Depends on how smooth, how easy to for the wheel of the equipment penetrate into the surface. So that determine the rolling resistance factor. So that's what we have, table 4.1. And then the next total resistance, rolling resistance, that's what we're talking about. And then